Hi, welcome back. This is Professor Ridge, and today's lesson is on section 2.4, another look at linear graphs. Okay, so starting off, example 1 here. So let's say I asked you to use slope-intercept form to graph the line, the equation f of x equals 2. Remember, f of x just y. So for slope-intercept form, we know it's mx plus b. So since there's no x term in here, it's 0x. So our slope is 0, which we can write as a fraction for a rise over run. And then the y-intercept is 0, 2. So I can start here, 0, 2. So that's where it crosses the y-axis at 2. My slope's up 0 over 1. Up 0 to the right 1. Up 0 to the right 1. And you see you get a a horizontal line. Draw my line through it. And so if you have no x in the equation, y equals 2, y equals 5, y equals negative 1, the result's going to be a horizontal line. Okay, so the slope of a horizontal line is 0. The graph of any function of the form, so we have f of x equals b, or remember, f of x is just a way to say y. Y equals b is a horizontal line. So if your equation has no x in it, just y, or f of x equals a number, then it's a horizontal line and it crosses the y-axis at 0b. And then one more way I want to talk about it. If we go back to the very first way of graphing it by making a table, and so if I asked you to graph y equals, say, negative 1, and I ask you to make a table, we'll do the short version, xy. You get to pick x's, plug them into the equation. So if I plug in x into the equation, well, there's no x, but y has to be equal to negative 1. So you could think of the equation as restrictions on what x and y have to be. And since there's no x in the equation, x could be whatever you want it to be. There's no restriction on x, but y has to be equal to negative 1. So x could be 1, but y has to be negative 1. X could be 2, y has to be negative 1. Then when you go to graph that, 0, negative 1, 1, negative 1, 2, negative 1, you quickly see that, oh yeah, that's a horizontal line. And I can draw the line through it. And there you go. So again, if you have y equals just a number, and so it's an equation with no x in it, it's going to become a horizontal line. Okay, now let's look. What if I switch it and ask you to graph an equation that had no y in it, but just x? So graph x equals negative 3. Now, if we go back to this technique of making a table and picking numbers and plotting points, well, first of all, you can't even do it slope-intercept form because slope-intercept form is specifically y equals mx plus b. Well, if there's no if there's no y in the equation, you can't put it in slope-intercept form, so that doesn't work. So we go back to our fundamental graphing technique of making a table. We're going to pick numbers for x and then see what y is. But the problem is there's no y again. And if we go back and think an equation to make a graph is a picture of the solution set. So we need points that makes this equation true. So what would make this equation a true statement? And the answer is, well, x has to be equal to 3. So x has to be 3, and then what's the restriction for y? If x is negative 3, we don't care what y is because there's no y in the equation. So x has to be negative 3, but y can be whatever I want it to be. It could be 0. X has to be negative 3. Y could be 1. X has to be negative 3. Y could be 2. If you plot those 3 points, negative 3, 0. Negative 3, 1. Negative 3, 2. You quickly see that, oh yeah, that's going to be a horizontal line. Oh, I'm sorry, a vertical line. So that's the equation x equals negative 3. Now if I asked you what's the slope of this line, and we counted on the graph here, we know we're going to go, so starting from the point negative 3, 0, we're going to go up 1, to the right 0. So it's up 1 over 0, which is undefined. So make a note that all vertical lines, the slope is undefined. Has no slope. Okay, so vertical lines, the slope of a vertical line is undefined. So hopefully you said that. We just covered it. So the slope of a vertical line is undefined. So we don't want to remember that. And also the graph of any equation of the form x equals a number, x equals a, is a vertical line that crosses the x-axis at the point, whatever a is, whatever that number is. See, that's a, 0. So that's on the x-axis. All right, let's say I ask you a question like this: find the slope of the line. Now be careful. So we got 3y plus 4 equals 12. And remember, to find slope, you want to put it in slope-intercept form. So you got to get the y all by itself. So we get 3y equals 8. And then divide both sides by 3. So y equals 8/3. Now remember, it's y equals mx plus b. So the slope is equal to 0, and we know that this is going to be what kind of line? And hopefully you're saying horizontal line. Okay, so same question, find the slope of the line. Now, I've had questions similar to this on the test, and a lot of students would get it wrong because they would say 3 because mx plus b, but it's wrong because this equation has no y in it. So there's no way to put it in slope-intercept form. And if you were to solve it for x, so you can see it's a vertical line. since there's no y. So actually I wouldn't have to even solve this. If I asked you to graph it, then I would do this. Divide by 3. So x equals negative 2/3. Of course I can flip it around and write x equals negative 2/3. So there's no slope in this one. Slope is undefined, right, because it's a vertical line. This one's a horizontal line. So be careful. Make sure if you're asked for slope, you have to put it in slope-intercept form. If there's no y in the equation, then obviously you're not going to be able to get a slope-intercept form. So, and the reason is because then it's a vertical line. Okay, so our next technique, graphing using intercepts. This is actually one of my favorite ways to graph in certain conditions. Okay, so first of all, to determine intercepts, the x-intercept is of the form, it's going to be some number 0. That's how you're going to be on the x-axis. So to be on the x-axis, you know y is 0, and x is whatever number where it crosses the x-axis. So it's some number a. Now to find the x-intercept, you're going to let y equal 0, since you know y is 0 from up here. And then you're going to figure out what that a is, so you're going to plug 0 in for the y and solve it for x. And that'll tell you what that a is. Now, similarly, the y-intercept is of the form, now to be on the y-axis, x has to be 0. And then whatever the y-coordinate is where it crosses the y-axis. So it's 0b. Now to find the y-intercept, what do you think you would do? And hopefully you're thinking, well, I'm going to let x equal 0. Since I know it's on the y-axis, the x-coordinate has to be equal to 0. And then I would need to figure out what that b is, so I plug 0 in for x and solve it for y. So that's the technique. And we know from geometry that 2 points determine the line, so this is the first point, A0, and this is the second point, 0B, and then I put my ruler down and draw the line through it. So it's a wonderful technique under certain conditions. So let me give you an example. So let's say I want you to graph using x and y intercepts. Something like 2x plus 3y equals 12. And the idea is you're going to find the x-intercept, which we know is some number 0. Oh, that's the y. Yeah, that was right. Some number 0. So I'm going to plug in 0 for y and solve for x. So let's see. We're going to plug in 0 for y, which 3 times 0 is 0. 2x plus 0 is just 2x, so basically that goes away. And now 2 times what equals 12, and obviously x would have to be 6. So now I'm going to plot the point 6, 0. I'm going to go to 6 on the x-axis, put a dot there. Alright, now for the y-intercept, same thing. We know y-intercept has to look like some number b on the y-axis, so let x equal 0 and solve for y. So the way I keep this straight, right, y-intercept, I'm looking for y, so that means x has to be 0. X-intercept, I'm looking for x, so let y equal 0. So we're going to get 2x, which is 0, plus 3y equals 12. 2 times 0 is 0, so that's going to go away. So 3 times y equals 12. So y has to be 4. Or you could just divide both sides by 3, just, normal algebra stuff. Okay, so now what I'm going to do is I'm going to go to my graph. And I'm going to go to x is 6, so let's pretend that was 6. And y is 4, so probably right about there. Put my ruler down and draw the line through it. I mean, how easy could that be? Not much easier. So that's 2x plus 3y equals 12. All right, so let's look at exercise 30 or 63 in the book. They ask us to solve this equation graphically and then check your answer by solving the same equation algebraically. So, typically you wouldn't solve this graphically, but the idea is to learn the concept of what's going on here. As you go into higher math, a lot of times, especially with these of using graphing software, you want to be able to analyze what's going on. So this is a valuable technique. So what you do is basically, to solve this graphically, we're going to split this into two equations. So the left side we're going to make a function, or you can use y, it doesn't matter. And then the right side we'll make a different function. And what we're going to do is graph both these functions on the same graph, so they're both linear functions. The one on the left, f of x, is 4x plus 1, so we're going to start at y-intercept is 1. The slope is 4, so go up 4 to the right 1, up 4 to the right 1, up 4 to the right 1. Get my ruler out here. Okay, so that's f of x. And then now we're going to do the g of x, so the y-intercept is plus 11. Slope is negative 1 over positive 1, so we go down 1 to the right 1, down 1 to the right 1. I counted wrong. It's amazing that that line lined up right. Okay, so actually it's right here. So down 1 to the right 1, down 1 to the right 1, down 1 to the right 1. And then the idea is, okay, to solve this, so this one is y equals g of x. So when are these two functions equal to each other? That's the y values. So we want to, right here, the y value is 9, and we want to know when they're equal to each other. would have been better to use graph paper, but anyway, you could see that the answer, so when is g of x equal to f of x? Well, that's when if x equals 2, then g of x, the y value, remember g of x is the y value. If x is 2, the y value is 9 for g of x, and it's 9 for f of x. So if x is 2, both these functions have the same y value, so they're going to be equal to each other. So that's all we're doing is looking for the intersection point. We're asking to find the x when the y values are equal. So again, you split them up. Y equals 4x plus 1, y equals negative x plus 11. Graph them. Where they intersect, the x value is the solution to the original equation. So x equals 2 is my solution. Now, they want me to check it by doing the algebra. Okay, so let's see, get all the x's on the same side. So we get 5x plus 1 equals 11. Subtract 1. 5x equals 10. Divided by 5, x equals 2. Now obviously that was way quicker than doing the graph. But like I said, later on, when we do some things that, it's actually, there are things that where you look at the graphs, when, especially with graphing software, you want to be able to use this technique where you graph them, or just plug it into a graphing calculator, graph f of x, graph g of x. You look for the intersection point, and then you know your solution. Okay, so that actually is a valuable technique, although you would never use that technique for a problem like this. All right, so that concludes the lesson for section 2.4. Go to my math lab and do the exercise there, and I will see you next time.